6.4a is nth roots, and before we get into these examples, I'm going to show you some other examples. So some square roots that you should know. You should already know a lot of the square roots. Square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, and so on and so on. You know, list out as many as you know. We've seen the square roots kind of a lot. As many of these as you know, the more you know, the better. Usually, you can get away with knowing the ones up to 100. Might be better if you can go up to 144. Square root of 121 is 11. Square root of 144 is 12. Square root of 169 is 13. You don't have to go much past that. Much past that, you're using a calculator for, I think. Okay, but we haven't had a lot of experience with cube roots or fourth roots. So a square root is when you have a number times itself to get you to a number, all right? 4 times itself is 16. That's why it's a square root of 16. But a cube root is a little bit different. Cube roots are a little bit different than square roots. For a cube root, you've got the radical symbol. It's not called a square root sign, it's called a radical. But it's got a 3 inside that little check mark part of the radical. And so that says the cube root of 1. And what the cube root of 1 is looking for is what times itself times itself times itself equals 1. All right, so 1 times 1 times 1 is 1. All right, so that one's easy. Cube root of 1 is 1. So the next one, in order to think about what would go inside the radical, you'd need to think about 2 times 2 times 2. 2 times 2 times 2 is 8. Very good. So the next one that maybe we should know is the cube root of 8. That one comes up kind of a lot. The cube root of 8 is 2. All right, you don't have to have this memorized because you can use a calculator, but it helps kind of, the more you know, it just kind of helps, all right? So cube root of something equals 3. In order to figure that out, it'd be 3 times 3 times 3. Anybody know what that is? Very good. So cube root of 27 is one that maybe we would know. Cube root of something equals 4. 4 times 4 times 4 is 64. Very good. So that's one that we would know. Cube root of this equals 5. 5 times 5 times 5. Very good. 5 times 5 is 25. Times 5 again is 125. Okay, so these are cube roots. And we don't really see, I think the next one is 216. Cube root of 216. But again, once you get kind of big enough, we're using a calculator and we're not really memorizing stuff. But I'm just saying, the more you know, the better. So a fourth root of 1 is 1. Now we're talking about 1 times 1 times 1 times 1. We're talking about something 4 times. And so the bigger you go, the kind of harder it is, the bigger those numbers go. So in order to do the fourth root of something equals 2, 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 again, 16. Very good, very good. So the fourth root of 16 is 2, okay? And you know, it gets really big really fast. So 3 times 3 is 9. 9 times 3 is 27, and 27 times 3 is 81. Another way to do it is if you think about 3 times 3 times 3 times 3. If you put these two together, that's 9, and you put these two together, that's 9. 9 times 9 is 81, okay? So I really don't know that I would know anything. I think maybe the next one is 216. The fourth root of 216 is 4. You know, to check that, one thing you could do is 4 to the 4th power. Oh, 256. So I was wrong. That's not 216. That's 256. Okay. So there you go. Goes to show you that you don't really have many of these memorized once you get up to a certain level. Okay, now, if I wanted to do the fourth root on a calculator, some calculators have a root button. It looks like um, it has like a N and an X on it or something. It's kind of confusing, but I don't ever use it that way. Everybody watch how I would type in the fourth root. Basically what I would do is treat it like an exponent. The fourth root, it's like 1/4. All right, it's like a 1/4 exponent. So I would say 256 to the, and then I want to enter a 1/4, but in order to do a fraction, you need parentheses. So I think that's the easiest way to do it because they're all the same at that point. If I wanted to do the third root of 216, the third root of 216, I'd say 216 to the 1/3 power. And that's going to be 6, okay? I think that's the easiest way to do it because everybody's calculators can do that, as long as you've got a calculator with parentheses. Now, you might have some kind of other button with an NX button, but I think that one's kind of hard to use. So I like doing it this way. They're all the same. Now, what's going to happen today is you're going to get variables. And it looks like a mess, and it looks like it's going to be really complicated. But the ironic part is the variables are going to be easier to do, I think, than the numbers. Okay, the variables are going to be easier to do than the numbers. But what you have to think about is you have to think about that fraction. The fourth root is like a fraction 1/4. The third root is like a fraction 1/3. And a square root is actually like a fraction 1/2. If I did, let's say, where are we at? Right here, this one right here. The square root of 64 is 8. Everybody knows that, right? Everybody knows that. But what you might not have known is 64 to the 1/2 power. 64 to the 1/2 power is the same thing as the square root of 8. Okay, so a square root is like a 1/2 power. A cube root is like a 1/3 power. A fourth root is like a 1/4 power. We're talking about fractional exponents. All right, so square root of 144a. All right, so write down some examples on the back. Okay, you've got lots of room on the back. Write down some examples here. Square root of 144 is 12. We should probably know that. You can type it in on your calculator. Square root of 144 is 12. But then there's this square root of a part. And anytime you can't evaluate it or simplify it, it's just going to stay inside the radical. And so the answer looks like that. So write the problem, write the answer. You're not going to have to show any work. You're pretty much always going to be able to just write the problem and write the answer. Okay? Now, let's look at number 10. Actually, I didn't start at 1, but whatever. Okay. So I always do it kind of in 2 phases. I do it in the number phase and I do the letter phase. All right. So look at number 10. It says the cube root of 1000 x to the 8th, y to the 2nd, z to the 3rd. That looks really, really super complicated. Okay. The number part, I would get out my calculator. And since it's a cube root, that's a 1/3 power, right? That's a 1/3 power. So 1000 to the, and it's got to be in parentheses. If you don't put it in parentheses, you're going to get it wrong. 1/3. 1000 to the 1/3 is 10, and that should make sense because it's 10 times 10 times 10. 10 times 10 is 100, times 10 again is 1,000. The cube root of 1,000 is 10, so I'm going to write that down, 10. But now I have to do the exponent part, all right? And I'm telling you, the exponent is a lot easier than you might think. It looks like it's going to be really tough, but it's not that bad. Okay, so we think of that cube root as something to the 1/3 power. We think of it as a fractional exponent, all right? And so fraction we think about division. Basically, what you have to do is divide 3 into 8, okay? So I want you to think about this. How many times And you don't even have to do like decimals or anything. All you have to do is tell me how many times does 3 go into 8 evenly? 2, right? 2, right? Then how many would be left over? If I did the division problem, if I said 8 divided by 3, okay, and you should be able to do this pretty much in your head, but I'm going to say, okay, 3 goes into 8 twice, and that's 6, so we subtract 6, and that's 2, right? I don't even have to go farther. I don't even have to do hard division or decimals or anything. All I have to do is say that's kind of a remainder, and I'm in good shape. Okay, if you can get to 2 remainder 2, you're in good shape, because what's going to happen is this. Okay, this part, the part that comes out even, is the part that comes out of that symbol. Okay, it gets to come out of the radical and it becomes x squared, but this part is the remainder and it has to remain inside the radical part. Okay, so we're going to have leave some space. We're going to have the cube root, and we're going to have 2 of those x's still inside of there. Now, this blows people's minds at first because they don't know what in the heck I'm doing, but all I'm doing is I'm doing a simple little division problem. 3 goes into 8 twice with 2 left over. The leftovers have to stay inside. All right. Now, you look at the y term, and you go and you're like, well, how many times does 3 go into 2? And you're like, well, it doesn't, right? It doesn't. It doesn't go in evenly at all. And so nothing gets to come out. Both of those y's have to stay inside the radical. Okay, they have to remain. They're both remainders. Now you go and you look at the z and you say, how many times will this 3 go into this 3? Once, with no remainder, right? It goes in once with no remainder, so that one z gets to come out. And that's z to the first, by the way. You don't need a 1, but that's z to the first. You don't have anything remaining, okay? That is the answer to this problem. Now, I know that looks like rocket science at first, but they're all the same. We just keep repeating and doing the same thing over and over again, okay? So let's look at number 13, okay? It's a square root this time. And you should probably know the square root of 10 without a calculator. What's the square root of 10? What's the square root of 100? I just gave you the answer. Square root of 100 is 10. Oops. Okay. So a square root is like a 1/2 exponent. All right. It's like a 1/2. And so that number is like a 2. And we're talking about 2 goes into. All right. It's like a division problem where 2 goes into. And so when we look at the x, we're looking at this 3. Essentially, we're dividing 3 by the 2 from the square root part. Okay. So your question in your mind has to be, how many times does 2 go into 3? Once, right? And so you've got a remainder 1. So 1 comes out, 1 stays in. That's my thought process. 1x comes out, and 1x has to stay in. It's not. It's on the back. I'm doing extra examples because I didn't think there were enough on the front. All right. Now you look at the y, and it's the exact same thing. 2 goes into 3 one time, so 1 comes out, and there's going to be a remainder 1, so 1 stays in. That's the answer. Okay. Once you know what you're doing, these things go fast. All right. Let's look at number 14. Okay. It's a cube root. And so if you don't know the cube root of 216, you're not alone. There's a lot of you that don't. But what you can do is say 216 to the, it's a cube root, so that's a 1/3 power. 6 times 6 times 6 is 216. So the cubed root of 216 is 6. I write that down. Now we're going to do the letters. Okay. All it takes is, how many times does 3 go into 4? Once, with how many left over? 1. So 1 comes out and 1 stays in. Now what about the n? Same thing, right? 3 goes into 4 one time, so 1 comes out. There's 1 left over, so there's 1 left over. There's a remainder 1, so 1 has to stay in there. All right, so let me see if there's a more interesting example over here. Let's look at number 6 right here. Number 6. It's a square root. Square roots we know. What's the square root of 64? Square root of 64 is 8, correct. Okay. Now what we're thinking, but we don't really need to write down, is the square root is like that 1/2 exponent. That's a root 2, okay? It's the second root. It's like a 1/2 power, all right? And what we also don't need to write down is that's m to the first, right there. And so when you start looking at the letters, you start looking at division, okay? How many times does 2 go into 1? It doesn't, right? 2 doesn't go into 1 evenly. And you can start talking about decimals if you want to, but I don't. Okay, 2 doesn't go into 1. So that 1 is all remainder. That m is going to remain inside that square root. Now look at the variable p. How many times does our 2 go into that 2? Once. With what kind of remainder are we talking about? 0. So 0 p's remain inside the square root. 1 comes out, 0 stay in. How about the q? 2 goes into 4 how many times? Twice. Is it evenly? Is that even? Okay, it goes in twice evenly. That means there's no remainder. That's my answer. All right. So I know it's kind of tough. I know it's kind of tricky, but we're going to do more examples. So turn over to the front now, and let's look at this worksheet here. So number 1, it always baffles me when people see this and they forget stuff that they would have known. You know, it's like this problem right here. If you hadn't come to school today, you'd have known number 1. Square root of 36 is 6, and don't let my new lesson make you miss that. We know square root of 36 is 6. Done. Number 3, square root of 100 is 10. That's easy. You knew that. Okay, don't let the new material erase your brain and forget old material. Number 5 is the cubed root of 64. Some of you might know this one. Okay, that means what times itself is 64. Those of you that do not know that one, you can enter this on your calculator. 64 to the 1/3 power. What's it going to say? It's going to say 4, right? It's going to say 4. So the cube root of 64 is 4. Okay? Number 7, we've got a square root of 36, which is 6. And now we've also got a square root of m to the 4th. All right? Now remember, a square root is like a root 2. And we don't have to write that root 2. Square root is like a shortcut. It's one that we see all the time, but it is a root 2. It's like an exponent 1/2. But you're taking that 2 into the 4. Right? How many times does 2 go into 4? Twice, right? And it goes in even. It goes in evenly. There's no remainder. 6m squared. 6m squared. Okay? Number 9, square root of 100 is 10. Okay? We're doing a square root, so it is a root 2. And so you need to take that 2 into each of those exponents there. How many times does 2 go into 2? Once, and it goes in even, so that means there's nothing left over. How many times does 2 go into 3? Once, with 1 left over. So that means the 1 comes out, and then there's 1 left in. We don't have to say y to the first, but that's what I mean. Y to the first, y to the first. One comes out, one's left in. How many times does 2 go into the 2? 2 goes into 2 once, right? So one of the z's comes out with no leftovers. The leftovers or the remainders always have to stay inside the radical. If there aren't any leftovers, then there isn't any more radical. Okay, next one. Cube root of 125. Okay, maybe you don't know that one. You go 125 to the, it's got to be a fraction though, 1/3 is 5. Cube root of 125 is 5. All right? Now, the x and the y don't appear to have any exponents on there, but they do. It's just an exponent 1 that you don't normally have to write. I don't have to write the little exponent 1. X is x to the first, and we all should know that. So in this problem, you're saying, how many times does 3 go into 1? It doesn't, right? 0. So 0 come out, and that 1 is the remainder. The 1 has to remain inside. So actually, both of those are going to do the same thing. They don't come out. Nothing comes out because the 3 doesn't go in evenly. Okay? Square root of 400. Maybe you don't know that one, but it's 20. Square root of 400 is 20. Or if you typed it in as 400 to the 1/2 power. Most people won't do it that way, but it's the same. It's the same thing. That's the same thing. But that's going to be a 20. And then we have to remember, since it's a square root, it's a root 2. It's the second root. Okay? And all we have to do is take 2 into each of those exponents. How many times does 2 go into 4? Twice, and it's even. So that all comes out, no remainder. 2 goes into 3 once with 1 remainder, right? So a y comes out and a y stays in. 2 goes into 2 once evenly, so that comes out. Once you get it, they're fast. But you got to get there first. That's why I'm showing you a bunch of examples. I think the negative's kind of tough, but you got to have a negative times a negative times a negative. It's going to be -4 times -4 times -4. That's what it is, all right? The cube root of -64 is -4. It's kind of tough to enter that in on a calculator. Sometimes it'll give you like a weird thing. I don't think technically this is correct because it's not hitting that -64. I think this is going to give me an error. I can't remember. Yeah, I've got something coded wrong in there, so that doesn't work. I think your calculator will work though if you've got a different one than this. But basically, if you just did 64 caret 1/3, I mean you're looking at 4 definitely, but it's got to be -4 to get the negative. All right, so we've got a -4 here, and then it's just the same thing over and over. 3 goes into 7 how many times? Twice, with how many leftovers? Twice with 1 leftover. So a squared, that comes out. There's 1 leftover inside. And it's the same thing, right? 3 goes into 7 twice with 1 leftover. Okay. Number 17, square root of 36 is 6. Sometimes people get into the mode of just chopping it in half. And that's not a square root. Square root of 36 is 6, not 18. You've got a root 2. 2 goes into 4 twice. 2 goes into 3 once with a leftover. And 2 goes into 1. No, it doesn't. That's leftover. There's your answer. 19, last one. You've got the 5th root of 32. That means something times itself times itself times itself times itself. Okay? You know? It's 2. That's right. Okay, and you see this one every once in a while, but but we can do 32 to the 1/5 power. That's a fifth root. That's a fifth root. Or if you wanted to just kind of guess and check, you could say, well, what's 2 to the 5th power? Okay, that's it. 2 to the 5th power is 32. Fifth root of 32 is 2. Now think about it. How many times does 5 go into 6? Once, with how many left over? Right, 1 remainder 1. So you're going to have 1 come out, and you're going to have 1 stay in. 5 goes into 4, how many times? Right, 0, with 4 leftovers, right? It goes, so 0 come out, and 4 are left in, so into the 4th. 5 goes into 7, how many times? Once. So 1 comes out with how many remainders? How many left over? 2. So 2 stay in. And that's it.